Okay, so then let me just kind of very briefly give context. So this call is kind of like meant to be a bit more of a focused working group session. We had like 2 weeks ago, I think, 2 and 3 weeks ago, we had two calls where Vitalik kind of presented his state expiry proposal, and that specific flavor of state expiry uses address space extension in order to basically make it efficient, basically make exclusion proofs efficient. So like you'll have these trees that expire over time, and you do not always have to go back to the very first tree and kind of like prove exclusion of an address that you want to use for the first time all the way through history. You have this nice format of kind of an extended address space where you have like a period number in there, and so you know that some addresses are fresh and you don't have to prove history for them. And so that's the context, but of course, address space extension is tricky. Until now, addresses in the EVM were 20 bytes, and now we want to move to 32 bytes if we go with address space extension. So there are quite a few issues, and Vitalik had like a sketched out proposal. Then the Ipsilon team came in and tried to really kind of concretize that proposal, change it a bit in the process. And then they looked into kind of like the implications there a bit more and wrote up this document. And Isaac, one of the authors there, is on the call and will kind of lead the discussion on where to go from here, basically, I think. I think the goal basically for today would be to get a better impression of how realistic is address space extension in the short term, right? Like how realistic is it to do address space extension on a 1 to 2 year timeline? So can we base state expiry on top of it? Okay, yep. Alex, you want to take it from here?
Thank you, Ansgar, for the intro. In the end, I'm not going to share the screen because Zoom only allows to share like the browser entirely and not like a tab. But Micah has shared. Sorry,
you can break out the tab into a separate window, and I think it'll let you share just that window.
I have like a bunch of tabs and windows, and Zoom only allows me to select the browser instance and not even a window. For some reason.
Okay.
So sorry for that, but Micah has shared the document in the chat, and yeah, I hope that everybody has read it anyway. And I also shared another document which is empty, where we can just mark down any decisions or ideas or anything else we come across this call. It's open to edit for everyone. And as regard for the process, I hope that we would maybe go point by point on this document. Some points would probably take longer to discuss, others probably shorter. But since we have like 15 points and we have like an hour, that means on average we shouldn't spend more than 3 minutes on each. So we won't make it all the way to the end. Thank you, Micah. I think you have shared the doc. So let's just start with the first point, which is just a generic feature of this whole address space extension. That if we have address space extension, that means we have multiple ways to arrive at a account, an address based on a private key. And in the first case where we just introduce address space extension without introducing state expiry or anything else, that means we will have two kinds of addresses. We will have the current legacy addresses, which are the short ones, and we're going to have the long ones, which likely only have like a version number in them and nothing else really, but have more bits for the hash than the current format. And in that case, we're going to have two different addresses which can be generated from this very same private key. However, when we introduce state expiry, this will become way more complicated because for each epoch there will be a corresponding address for the given private key. And then lastly, if we do have these compressed addresses, which is not set in stone, that might be like yet another representation of the same private key.
So why would state expiry be a problem here? My understanding with state expiry is it would operate entirely on long address only, and the transposition of short to long or the conversion of short to long would just be basically at the EVM layer, just so it can deal with contracts.
So each epoch you can create an account, right? And you can create an externally owned account in each epoch. And you can use the very same private key. to do that in multiple
right.
epochs.
But like, so when first epoch happens, like when we make the transition to state expiry, my understanding, which it could be very wrong, was that basically like internally everything is converted to and treated like the long address. Like we use a long address everywhere internally, and the only reason we need to do this transposition is because of contracts and the EVM. Is that not correct?
I don't think that's quite correct. So like if you look at the short address here, so the moment we would do address space extension, the short address would basically become a long address just with leading zeros. So kind of like the exact same
Right.
line and just leading zeros. And so that would be a different account from the one that is listed under long. Both have the
I
same
see.
private key. Yeah.
So
but
the
there would
issue
be
here-
different accounts.
So the issue here is the Merkle tree, I believe, stores accounts as like a hash of the address. Is that right? And then we can't reasonably update the whole Merkle tree until epoch 2 or 3 or
Well,
whatever it is.
No.
You can never you can never update it, because that would. Okay, I think we are steering away from this point, but I mean this is relevant too. Basically, in Ethereum, we don't require the existence of a account. You can just transfer or interact with any account, whether there exists a private key for it or not. And therefore, it's not possible to, even with a rainbow table or somehow, it's not possible to retrieve the corresponding public keys. So there's no chance that at any point in the
I see what you're
future,
saying. Yep.
we're going to be able to change the entries in the tree. They're always going to be the short
well,
addresses.
You need the private key or the public key in order to generate the long address.
Yeah.
Is that what you're saying?
Yeah.
We cannot generate a long address from a short address.
Yeah.
Of course, what you could do is you could have some super complicated merge logic that merges. Like as soon as you use the long address, it kind of is merged with the short one. But I like that's explicitly. I don't like a not part of this proposal, and I think it would be a bad idea.
Yeah, we toyed with that idea, but it's very complex. But I guess just getting back to this first point, as long as we agree that you can use the same private key to represent multiple addresses in different epochs, I'm not saying this is an issue, but this is a property. You know, at this point, you will have multiple addresses corresponding to the same private key. And is that a problem? I'm not sure, but yeah, I think this is a new property we don't have today.
Out of curiosity, does this or other problems go away if we assume that the address extension does not increase security of accounts, like the collision issue? For example, if you can generate a long address from a short address by just prepending the epoch it was created in, do we alleviate a bunch of problems? Or do
No,
we
I
still
don't.
have most
I
of them?
don't think you can. I don't think this property cannot be. This cannot be removed.
And I don't think it makes sense to kind of consider it like a problem to be solved. It's more like a property of this proposal that is somewhat kind of unusual, like or different from how things were before. And so we have to just decide: is that does that constitute a problem, or is that just like a UX difference that people will have to get used to? And
Well,
I'm personally of that opinion.
So I generally do agree that we should increase the bits of security. But I would be loath to find out that state expiry gets halted entirely because we couldn't figure out how to do this. Whereas if we were to drop the increased number of bits of security requirements, we could then get state expiry super easily. Like it would just suck to miss out on state expiry because we tried so hard to get more than
we might be talking kind of like beyond like kind of about different things, because I don't like what you're referencing here is just these extra 6 bytes of just like a longer hash portion of the long address. That to me is like a completely separate. I don't see a relation between that property of the long addresses and the general property that now you have multiple addresses for the same private key. Even if you were to continue to only have this 20-byte hash part of long addresses, that would still be the same situation.
Well, so if you were able to convert a short address to a long address without having access to the public key, then hypothetically, one could imagine a scenario where we actually do update the full Merkle tree and we do convert everybody to long addresses, which means state expiry only has to deal with long addresses. It doesn't have to deal with short addresses anywhere. So everybody only does have one address. It's just there's two ways of expressing it. One is with the short address, one is with the long address.
So for one, I'm not sure like about the implications there. It seems tricky, but also once we then actually do state expiry and we have multiple periods, then you have one address per period anyway. That property just cannot get rid of. So there will be one account per period. So like if potentially, right, you don't have to use that account. So if I just have an EOA in period 3, then I can still use that same EOA with that address in period 15. But I could also, with the same private key, create an account in period 4, 5, 6, 7, 8, and 9, and so on. And so those would be different accounts on the chain. They would have a separate balance and so on. And like I control all of them with the same private key. So that's just a property of the system.
Yeah, I hadn't considered that. Is that a hard requirement, or like can we do something to say, hey, if you already have an address in Epoch 1, you cannot use the same public key or create a new address in Epoch 3?
And wouldn't you need to submit like proofs that no such address exists? I mean, that's the only way to do it, right?
Oh, I see. So the idea here is if we do reference the account in Epoch 3, then it would get upgraded to an Epoch 3 account?
Not really. So it would still be an Epoch whatever where it was first created, Epoch 0 or something account, but it would now also live inside of the Epoch 3 state tree. And so it would no longer require kind of extra proofs, but it's still a Epoch 0 address.
And the balance in both the Epoch 1 address and the Epoch 3 address would mirror each other. Is that correct? Like you wouldn't have two separate accounts. You would have one account that has two addresses.
No. So if you basically if you have a long address with an epoch period prefix of letter 7, and then you have create a different one with the same kind of hash bit, but like in period 9, then those have separate balances. They are controlled by the same private key, but they have separate balances. If you just copy over your address, like your period 7 address to period 9, because now we live in period 9, you just kind of continue to use it, then the balance is the same because it's still the period 7 address that you just keep using.
Gotcha. Okay, so that aligns with my understanding. What I'm unclear on is why we need this feature where we allow people to have both Epoch 6 and Epoch 7 addresses that have the same everything except for the epoch. So like where the only difference in the address is the first byte.
It's not really about allowing. I mean, this is by design. So you could try to invent a scheme where you try to disallow it, but it's
okay. So you're saying, so if the reason I'm impressing on this is just I want to make sure that we're not introducing requirements that are causing problems for ourselves that we can't get rid of, because this is a very hard problem. And so like if this is something that's like, hey, by default this is the behavior we get, but if removing that behavior gave us some benefit, then that's on the table. That's fine with me.
So I think the problem is that you have like Epoch 7, stuff that happens in Epoch 7 can't depend on whether or not something happened in Epoch 1. Because if something happened, if say I created an address in Epoch 1, if that changes the behavior of stuff in Epoch 7, anyone who wants to do something in Epoch 7 then has to go and find out by producing long proofs whether or not I created that account in Epoch 7. So you just can't do it.
Yeah, I think that's exactly it.
For new accounts, yes. Like in order to create a new account, you have to have the epoch prefix. I do agree with that part as a requirement.
Yeah, and so then the question becomes like, why I don't even like. That's why I'm so confused. We talk about this so much. Like, I don't even see the problem. It's indeed like a somewhat new property of the system that now there's no longer like a one-to-one mapping between private key and the on-chain account. I just like, and that will have some UX implications, but I just don't. Yeah, that seems not like the problematic bit of this whole.
Yeah, if this doesn't bite us, then that's fine. So maybe a question for Alex. All the items on this list, are they things that are problems we need to solve, or is this partially a list of problems we need to solve and partially a list of things we should be aware of and think about and consider if they're problems, but aren't necessarily problems.
But we try to, it has all of these, and we try to differentiate them by like the prefix property or feature or the ethics.
So this one might just be something to keep in mind and think about, but we aren't aware of any specific problems this will cause, this property.
I mean, it definitely will cause extra work on the UX side and potential confusion.
Okay,
but
that's fair.
On the protocol level, I don't think it will cause any great issue.
Right. And this is basically like if a user puts in their private key to some wallet or something, that wallet needs to then find out, do they have an Epic 1 address? Do they have an Epic 2 address? Do they have an Epic 3 address, etc.? And that's painful.
Yeah, I mean, that kind of would work like how BIP32 works on Bitcoin, right? It just checks which paths are used.
Yeah, okay.
But it's not that painful, right? Like your wallet would just kind of like only display those that have ever been touched by default or something, and usually that would only be a single one. And checking. Checking 5 or 10 accounts.
I hope the wallet wouldn't really be showing things like state expiry specifics to users.
No, but like if you just restore your wallet, right? You enter your passphrase and then not your passphrase, your seed phrase, then it would just have to find the account that you used to use with this seed phrase. You ideally, if you're in period 7, you don't want to restore 8 different addresses, and so like by default, it should only restore the ones that it finds on-chain state for.
Yeah, I'm satisfied. We can move on if anyone else has questions about this one.
Yeah, earlier you mentioned, I guess that there are some ways to at least reduce the duplication in terms of the like epoch 0 and the current short addresses. But yeah, as we discussed for going forward, unless there is a specific mechanism in place which rejects creating such addresses, it's just going to be there. But this rejection, I don't think this rejection can work nicely, because in any case, like token transfers or anything like that happens outside of the realm of the protocol. So people can definitely just transfer to such an address, and if we reject the creation of such an account, then it's just another way to lock up things. Yeah, but we definitely spent extreme amount of time on, well, I guess this is an important question. That's why it was number 1. But yeah, should we move on to the next point?
Sounds good.
Yeah, these next 2 points are more just like an explainer. And it sets the stage why this whole address space extension is complicated. And this comes from how existing contracts behave. And these 2 points are Solidity specific, because Solidity is the biggest, I guess, bytecode producer in terms of a number of accounts currently. I haven't fully validated whether Vyper does similar optimizations or not, but I believe they may do it. But Solidity, regarding Solidity, so one point is that these existing bytecodes can behave very differently whether they were compiled with optimizer on or off. In Solidity, addresses are considered like 160-bit number, and by default, there is masking applied. So for any kind of like handling this address value, there is a mask applied 460 bits. But then if the optimizer is, and by default the optimizer is turned off, and that means the mask stays for any kind of assignments and reads, etc. But if the optimizer is turned on, then some of these are removed. They're removed on stack items, but when they are read or stored into storage, the masking still applies. So that means if suddenly all of these opcodes returning addresses would output more than 160 bits in the EVM. Then depending whether a contract was using an optimizer or not, it will just behave differently and in various random ways. And then the second point is there is this thing called ABI encoder v2. So the ABI is just the specification how contracts and like external dApps interact with contracts. How do they encode the data passed between each other? And this ABI has a specific type for an address, which is 160-bit type. And in Solidity, there are two codecs dealing with the ABI. There is like the ABI encoder v1 or the legacy, which was there since the beginning. And then we have this ABI encoder v2, which has been enabled probably 2 or 3 years ago, but has been made on by default in the last breaking release, which was like 6 months ago. So there is a mix between what existing bytecodes use, but if they do use the v2, then input validation is much more strict. And that means if a input is low, like an address input is longer than 160 bits, then it will just revert, which I guess is nice because, you know, if you just pass like a long address to an old contract, they would just reject it. But anything which uses like the old ABI encoder, they will just silently accept it. They might truncate it, or they might not. It really depends on the version. So these two things are why all of this is kind of complicated.
Yeah, question. So basically, in my understanding, that basically means one thing to also point out here is that things like the call opcode, that are all the opcodes that take in addresses, I think today just truncate the input, right? So like if the like leading 12 bytes of whatever you have on the stack as the address are not 0, they just truncate that and ignore that. And so indeed today, basically, you could have like dirty addresses reaching the call opcodes and the contract still works. And so in my understanding, that means that in order to just keep backward compatibility, contracts that like have legacy addresses, so like accounts that live in this version 0 space, would forever have to keep exact behavior as today. So basically they would have like all the call opcodes and everything would have to truncate the first 12 bytes, which would have to ignore that and all of this. So basically there would forever be no way, even if you deploy a new shiny Solidity 1.0 or something contract at an old, within the old kind of space, if that's somehow possible, then basically those would always, like they could never directly call into the extended address space. They would always have to go through these compressed addresses. Is that like a fair kind of understanding?
Yeah, so there's these two properties, yeah, and exactly I mean, that's why the masking can be removed because all of these opcodes taking in an address will just truncate themselves. And yeah, I mean, as you explained, that's the reason we need to keep, like, if you don't want to break anything, we need to keep existing bytecode not to change any behavior. And that's why we need some kind of a translation if old contracts want to interact with new contracts. And the question arises whether you want this interaction, first of all. And it seems that we definitely need some kind of interaction. Otherwise, like there's no way to migrate. So like another option, if you don't have like a translation, another option would be to somehow upgrade existing bytecode with new one in like an opt-in basis, migrate like old accounts to bytecode which can handle both. But this seems to be, you know, quite a bit more complicated thing, and yeah, that doesn't seem realistic.
Yeah, and like one question that I had there specifically is, so basically one of the design goals here that I'm really kind of focused on is to make sure that long term the kind of the situation won't be much more complex than had we just started with a 32-byte space in the first place. So like when we later on talk about the translation map, I really like the ideas of like having at least expiring translation map or something where like we don't have to have this extra overhead forever to the extent or something. But also here already, one design goal that I would have is that new Solidity contracts that are designed to be deployed at like new accounts that are period aware and all of this, that they don't have to have like extra branching and checks to basically understand where they execute, right? Because if the opcodes have different behavior depending on if they are executed in a legacy context or in a new context, worst case Solidity would basically always have to check, am I deployed at an old address or the new address, and then kind of have branching behavior. Ideally, what I would want is that new Solidity code just kind of like treats addresses as 32 bytes, and then just kind of like it doesn't matter if it's deployed in an old or new context. But of course, the problem here is that if call and all these opcodes truncate, then a new kind of contract that thinks it can deal with long addresses all of a sudden can't. And so even if the opcodes like caller and origin and so on, they return short addresses in these short contexts from like the outside via call data or something, there could still be long addresses that reach these contracts. And so I'm just wondering, would we just assume that it's basically a user fault to deploy new Solidity code at old addresses, and then these contracts potentially just break? Or would Solidity just forever have to have like a case distinction where it looks at its own address and branches its behavior depending on this? What's kind of like our understanding of how Solidity would deal with this?
What?
This is more like a UX DevX question. It's not really a protocol question. And I mean, obviously people can deploy whatever they want today or in the future. You know, we don't really make safeguards. But I guess one hope from our side is with this somewhat related proposal on the EVM object format. If we have that in place, then it's easy to see, you know, have like, you would be easily able to tell if a bytecode is an EVM object format, and then if it's like the certain version which is designed to work with the long addresses, then it's easy to distinguish. But I'm not sure if we want to really cover like all this DevX and UX on the protocol level.
Yeah, it could be out of scope for today, but I still think that it would be unfortunate if we end up with a solution that just doesn't allow for good UX DevX kind of solutions, right? If basically whatever we do on the protocol side makes it really terrible for like forever to write Solidity contracts because they have this huge overhead every single time, that wouldn't be ideal. So I still think it's kind of like something worth taking into account. But yeah, I agree with you. It's kind of like it's not part of the core challenge.
So just to make sure I'm on the same page with you guys, the issue here is that if, let's say, message.sender returned a 256-bit address, some Solidity contracts that are currently deployed today will break because they don't truncate the first 12 bytes. Is that correct?
Right. And so message.sender in like basically message.sender now the behavior, the proposed behavior of messages of like caller, the opcode would be to check if I'm running inside a legacy context. So basically if the address that I'm deployed at is like a version 0 address, and if so, it returns a short address, and that is either the caller address if the caller address happens to also be a legacy address, or if the caller address was a new address type, then it returns the compressed format of that instead. That is basically a different behavior from the caller opcode than inside of non-legacy context, where the caller opcode would return the full caller. I think.
Yeah,
I might be wrong,
so,
but yeah.
And what I'm missing, not understanding why this is a problem. So like, yes, there's a little bit of, we'd have to have a conditional in the EVM that says, you know, if address starts with 1, then do return this, else return something else. That seems like a pretty minor issue.
I think Ansgar is speaking from the DevX point of view, where I guess your expectation, Ansgar, would be that Solidity would output bytecode, which can operate in both contexts, right? That it could operate under being a legacy account or be like a long address account. And it's certainly possible to do that because you can't just call like caller or origin and see if it's a long address, and if it is, or rather call address, your address, and see if it's a long one, and then have different behavior depending on that. I mean, there's no way to reject anybody trying to do that. But your concern is whether Solidity should do this by default or not, and we should avoid Solidity doing this. But I don't think this really applies, for the protocol design.
I think there may be a more salient problem, which is there will be people who deploy contracts in Epic One that were compiled sometime before Epic One. And so those contracts will not so even if Solidity does the right thing in next version, that doesn't help people, because I see people deploying Solidity code compiled with, compiler 0.4 still, like today. And we don't have a way of saying, no, you can't deploy that code because we know it's bad. People will deploy old compiled bytecode.
Right, and that's a problem on its own. So basically, that's a user fault that I don't think we can really do anything about, short of maybe something with the kind of object format thingy that Alex, you just mentioned. But besides that, it's basically we just have to accept that deploying old code at new addresses will just break. I don't think there's a way around this, really.
Okay.
I think you just have to treat it like the 32-bit versus 62-bit, like x86 distinction, and just say that bytecode is either old legacy bytecode or new post address space extension bytecode, and it just can't be one or the other. And you make that decision at compile time, and then you're stuck with it.
Right.
Also,
the problem is just that
it's not compile time check. You need to do it at a runtime check, and we don't currently have a way of checking whether the bytecode was compiled with a new compiler or an old compiler at runtime.
Well, no, I mean there could be check that just the new code does or something. But yeah, the problem is it doesn't automatically fail, right? If you just use old bytecode on a new address, unfortunately, at least right now, we don't really have a way of stopping you or just stopping the contract execution at all. It would still run, and it would probably work 90%, right? And then it would only break in some edge cases. And so this is really unfortunate. Ideally, what we would just want is that all contracts just don't work if you deploy them at new addresses. But if they almost work, that's a problem.
Can't we just use EVM object format for that, and just say when you compile post address space extension code, that it has to be EVM object format, and it has to have a flag in the EVM object format, like a table somewhere that says this is new style code, and if it doesn't, it immediately crashes when you try and execute it or something.
Yes, I was about to suggest the same thing. It just creates a dependency. It means we can't do address space extension, therefore we can't do state expiry until after we have the EVM object format, which maybe is fine. That might be the easiest way out of a lot of these problems, is just by saying, as a dependency of address space extension, we have the object format stuff.
Yeah, so the easy solution is just, depending on when any of this gets in, but let's assume that maybe this doesn't, well, I guess address space extension would get into the next hard fork, but maybe the object format gets into the next hard fork. And then the hard fork after that, the address space extension gets in, and we say that the object format v2, because there's a version byte in there. So now we only allow v2 to be deployed, which is like a long address bytecode. But yeah, I would suggest we move on, because this is very interesting. But yeah, I think this is more of a DevX question as opposed to the core issues we have.
Yeah, I think kind of we flagged it as a thing to further discuss. But yeah, probably best to now move to the translation map, because I feel like that's the big one, the big topic. Yeah.
Yeah, so this, I think the point, this 2A point, the inaccessible funds case, is also has a second part, which means when the user, so it's again like a UX issue. From the wallet side, they can, if they use the wrong encoding of this and just pass it on, use a compressed one. It's very easy to make mistakes. That's the whole problem. with having all these different kinds of addresses. And all of these mistakes can be initiated from the different wallets and dApps. And I don't think we can do anything about it apart from teaching wallets to act nicely.
Can you give a quick example of one of these failure modes? Like just to tell a little story about how someone screwed this up.
Yeah, we have nice cases in the test cases link. I'm not sure, Andre, do you want to give a clear example?
Yeah, there was actually a paragraph in this previous doc, not in this one. Yeah, the last paragraph in this section gives one simple example. So it's basically a new style wallet that accepts maybe both long addresses and short addresses, but then someone passes a compressed address to it. And then the transfer is initiated to this compressed address without doing a lookup because it was not added to the translation table before. So that's like the problem on the tooling level maybe. And then the transfer ends up at some not random but compressed address, which is not a valid address in the state.
Gotcha. Okay, so the issue here is that because compressed addresses are also 20 bytes, we can't distinguish them from legacy addresses. And so someone could get into a situation where they send some stuff or something, or they store something related to a compressed address when they meant to store it related to a short address. Is that correct?
Yeah, we can't distinguish between them unless this address is added into the translation map already and the wallet contract actually can access it and check it, make the lookup itself.
So question with that, and I don't think it would solve all the problems, but Vitalik had like a different proposal to do basically state expiry without address space extension, and there he proposed to find like a prefix that isn't yet used and basically do address state kind of reduction even. And could we use like a similar trick here to basically find a prefix that no actual address has used so far in Ethereum and just only ever use that prefix for compressed addresses? That would of course make them even shorter and so even less collision resistant, but at least you could, like, if you look at an address and it has this prefix, a short address, then you know it's only like a compressed address, whereas if it doesn't have the prefix, you know it's not a compressed address. Would that help?
I worried that we'd have to shave off a lot of bits of security to achieve that.
The main problem with that isn't, I mean, when you try to create something new and you collide with the prefix, then you get like a new address assigned. I mean, that's in the proposal. But I don't think it just addresses any existing, the problem of any existing account which is not created yet in the state, but is in like token balances or is, you know, like a destination of a create to or anything like that.
You mean with the same prefix? Or...
Yes. I mean, there's just a lot of
yeah.
accounts which are only currently listed as targets of like owners of different tokens. You know, a lot of people just get tokens to an address which never transacted before. And at some point in the future, they may want to transact with that address, but they haven't yet. So there's a ton of addresses in existence which are not represented in the state tree.
Sure, but if it's only part about finding a good prefix, then one, you can make very clear probabilistic arguments that like there's only like a 1 in 10,000 chance that that has ever happened so far. And also, if you want to be really certain, you could even do, at least for on-chain bit, you could do like more clever analysis and look at, I don't know, all the call data items that were ever kind of passed into contract or something, and make sure that there's never ever been a 20 byte value that had this prefix or something. I think if you really wanted to, you could find a prefix that doesn't have issues. I worry more that like it would completely remove collision resistance, even in the short term, from the translation map, which I think has really unfortunate implications.
I mean,
but
it's
I
a
just-
both.
yeah.
I mean, both the. I mean, if you probabilistically don't want to have any, I mean, collide with any existing address, even addresses used like in token balances, then you may realize that you want to have quite a long prefix, and that really eats into collision resistance of the
I think Vitalik was
remaining hash.
proposing 3 bytes. Was it 3 bytes? 3 or 4 bytes? I think that's sufficient.
That would surprise me.
But at the same time, yeah, even that might be sufficient to completely remove collision resistance, right? I think we're kind of 20 bytes is kind of still mostly infeasible, but I wouldn't be certain. I'm not an expert though, but I wouldn't be certain if 16 bytes are completely infeasible even today.
Also, yeah, I guess the distribution of the prefix or like the higher bits are not uniform across accounts, because at least for early accounts and accounts created by parity, there was this really early proposal, like in 2015, to have these addresses called ICAP addresses, which is like these international bank number encodings, which I believe can only represent like 143 bits or something like that. Which means a lot of addresses start with 0 for the first byte. So at least that may help in the sense that maybe there are more addresses starting with the 0 byte than not. So, well, obviously you don't want a prefix starting with 0.
Yeah, but of course, I mean, the overall point, by the way, of this point remains, right? Like just UX-wise, it's really easy to make a mistake. So if you just send in, basically, if you deploy a token contract at a new address, and then at some point you kind of by accident assign someone with a compressed address a balance, that can never actually ever be retrieved from that token contract, because yeah, the token contract internally will always, when it calls caller or something, it will always get a long address, and so it'll never get the compressed form. And because there's no actual real private key for the compressed address, basically so it's still really easy, even if we were to do something like this, to just make mistakes from the outside and use a compressed address where you shouldn't.
Yeah, and of course this is not a new problem. I mean, people can make mistakes already, and they're free to send whatever addresses, and they frequently do. But you know, with having these multiple ways to encode addresses, I mean, just the probability goes up for the number of mistakes wallets can do.
Can we make it so you can sign over your compressed address? Like
But this
basically
is
submit
not
a transaction with.
Yeah, but it's not about the transaction. This is I mean, it may not be you making that transaction inserting your address. You know, it may be the sender just uses like the wrong version of your address sending you something.
Right. So, but the issue is that if they, let's say they send you a token to your compressed address. So they say, hey, what's your address? You give them your compressed address for whatever reason. So they send you a token. Now there's somewhere in the state tree, there's a state entry that maps, you know, your compressed address to a balance. If I understand correctly, the issue here is that you can't actually sign a transaction where message.sender is your compressed address. Can we make that a possibility? Can we introduce a new transaction type that is just like every other transaction type, with the difference being that the message.sender for that transaction is your compressed address instead of your full address?
Yeah, I think this is connected to the last 2 points we have. You know, what should happen with EC recover and EIP 3074, because I mean, based on the very first point, right, you have a private key which can correspond to various number of addresses, and we need to do something with EC recover, extend it or something in order to recover all these different versions. And the same question applies to transactions, right? Whether yeah, I mean, the problem with transactions is right now we don't have the address, we just recover the address based on the signature. But in the future, if you have multiple epochs, then I suppose we need the epoch number in the transaction type. in the transaction, and then we will try to recover the address corresponding to that epoch.
Right.
Yes,
but-
at the least, we'll need that. And then I think we could also, in theory, have some other bit that says recover this as a compressed address versus recover this as a long full address. That way, if you need to withdraw some token that you got sent to your compressed address, you can. You just have to construct a transaction that recovers to your compressed address instead of recovering to your long address.
I think with all of these proposals, it's really tricky to think through all the implications. I like on the first impression that sounds feasible, but of course there might be kind of really tricky implications downstream. But also I think that would only solve the problem for compressed UA addresses. For compressed contract addresses, I assume then that would mean if you want to have full compatibility with these kind of situations, we would also need to introduce a new call to opcode or something, that, or like a compressed call opcode, and then every kind of new contract would basically have to have a call this function instead if you made a mistake downstream, so that now I'm using a compressed call opcode just so you can recover things. That kind of quickly explodes in complexity.
Yeah, it's fair.
Okay.
From the point of view of like legacy contracts, what's the difference between a legacy address and a compressed address? Like if I send a legacy address and a long address, if I send some money to a compressed address, surely that's just a legacy version of sending it to the long address that compressed address refers to.
So from the inside of an old contract, so if you actually run in the old address space and you then using a compressed address, or like basically would hopefully, of course, if the translation table works and the entry is still in the translation table, all these kind of things, but hopefully at least it would be the exact same. So the kind of the compressed address is only a pointer to the long address, and so all the money or whatever you're sending actually indeed arrives successfully at the long address that it was supposed to arrive at if you use the compressed form. I don't know if that answered the question.
Yes, it did.
Yeah, I think we only have 10. Sorry, Micah, do you want to go very quickly?
I'll try. Could we include something in the transaction that is similar to an access list, very vaguely similar, where we basically just say, hey, when this address is looked up, return the compressed address in this transaction. So
yeah,
if someone
that is one of the points using transaction access list instead of like an in-state translation.
I actually think that Micah was specifically referring to the case where even inside the new context where you could just return the full long address, you would still want to return the compressed address because you made a mistake earlier, and now you want to be able to kind of act as if you were the compressed address. And I think that part would really open you up to attacks, because then kind of users could set that for contracts that don't actually want to be compressed. And then, so you really don't want to just leave something like this up to the user. But yeah, I agree with Axel. So we should try and at least talk a little bit about the other topics here as well in the last few minutes.
Yeah, we move on.
Okay, just skipping maybe skipping like 2.b for the moment, because 2.c, d, and e are kind of related. So basically in 2.c, we say that because this wasn't defined like in the initial proposals, how does like this translation table works, how does like insertion works in terms of gas and reverts. And we think that it should work as if it would be like a regular address slot. And that means you cannot extend the translation map with a static call under static call context. And the insertion to the translation map should be reverted in case the call reverts. Any comments on this?
Is there any known problems with that approach, or is that just a thing when we build this, we need to make sure we do that?
Yeah, we don't see any problem with this, but we do see like complexity if we don't do this, because then we have like different rules on reverts, and this seems
only
fine
want
actually.
I would only want to comment on like, should the translation table expire or not, but that's probably not what you want to talk about
That's separate.
here.
Yeah. Okay.
Yeah, I think we can just move on if no.
Yeah.
Like
The
that seems
second,
fine and reasonable, and just a note.
yeah. I guess the next point is that it would make sense to make this translation map accessible to both contracts and off-chain tools, because right now, at least in the proposal, there's no way to access the map really. You cannot inspect the map. You cannot see what a input translates into or whether an input exists in the map. And yeah, we felt like that it would be nice for contracts to be able to check that, because then they could have safeguards whether something exists in the map or not. But yeah, I'm not 100% that we need this for contracts, but I'm more certain that such inspection capability must exist for off-chain tools. So like wallets should be able to check if something is in the table, because if it's not, then they may need to do like a poking transaction to. So in the case from externally, you are trying to interact with an old token contract, but your destination, like a recipient, is a long address, then the wallet would first want to check if the translation exists. And if it doesn't, it would need to send a transaction first, which ensures that the translation table is populated. So the easy way to do that is just to do like a balance opcode or something.
This feels like something that could very easily be solved by a precompile, and that seems very reasonable to me.
Yeah, I mean the off-chain kind of support, that should just be, yeah, that feels like it's even outside of consensus. Like the clients could just implement some interface for that. But on-chain, I agree. I even think it like ideally it should even be like a precompile where we can think of the state as being part of its storage. I mean, of course, we haven't had precompiles with storage in the past, but like basically, for all practical purposes, the whole translation map to me should just basically be a precompile with storage. That would be really that would solve a lot of these.
Yeah, that's the idea. And then you don't even need like an RPC method. It just can be called. And while this never happened so far in mainnet, there has been proposals like that. So a notable one is EIP 210, which tried to do that for block hashes. So there's this conversation to refer back to. Okay, so yeah, I mean, there's a bunch of other stuff. So what we noted as well is that the map size would be quite big. So as of like a month ago, there have been 156 million accounts in the state. And and that's for the past 5 years or 6 years. And let's say, even if the growth rate wouldn't continue as it is, but it would be slower, we could reasonably expect to at least have like another 150 million accounts, in a few years. But if like uptake of Ethereum is much faster, then this growth going to be bigger. But with 150 million new accounts, if they still want to interact with like the old contracts, like the existing stable coins and whatnot, then it's quite a lot of data to store in an in-state translation map. It seems like the bare minimum for 150 entries would be around like 9 gigabytes of data. And that seems to be a lot.
Right. And so just because we seem to be running kind of out of time, although I'd be happy to stay on a little bit longer, but like, of course, most people have to drop off. So just to flag this here, I actually like Matt and I, we at the Quill team, we've talked about that like previously, and like, because I think it seems like this translation map is really kind of, and specifically like the overhead that it kind of imposes on the network is really the main question here. So like, I think everything else seems like we can make it work somehow. The question here is just, and I think it's 2 dimensions. One, what gets added to the translation map? So I think somewhere you also have the question of like, should any long address that ever gets created immediately be added, or should it only be added once it's first accessed from inside the legacy context? So I think that's a really important one for me, because if it's only ever accessed on the legacy side, then at least kind of like over time, it will be like rarer and rarer that things get added. So at least that bounds it. If it, of course, every new address will always be added there, then that kind of like makes it grow forever. And then the other question, and I think that's also the big one, is like how kind of ephemeral versus persistent should it be? So I think one extreme is your proposal, like that's like under 3 here. So basically like make it completely ephemeral, only ever build it within a single transaction, then forget about it totally. The other extreme would be keep it forever and never forget anything about it. And then there would be like the middle case of just have it follow the normal state expiry rules. And I think the problem here is like to really get a good feeling or like a good solid understanding of which one of those would be the way to go. I think it's really important specifically here to do case studies of like, look at existing contracts, how would they be impacted? Like how easy would it be to do really undesirable behavior if you have like misses in the lookup table and things like that? So basically like, I really think that this is something that deserves like a lot of further study of like use case, like case studies and all of this to really like the line space. Like for example, my favorite is like only add once they're first accessed on the legacy side, and make them expire, but not completely ephemeral, and have like access lists and all of this to kind of like give users tools to further populate it if needed. But again, this is like a huge design space, and it's really important that we figure out, I think, which of these works by not being like too much overhead, but also not breaking too much of the legacy world. I don't know. That's all from.
Yeah, I don't think any of the proposals suggested that the table is populated on every single time when like there's a new address interacting on the network. It is only populated if a old context is trying to reach a new context. So it's not populated for everything, but if you, so one example is like DAI, which is quite popular, and DAI has really just seen one upgrade on the main token, right? When going from the single backing token to like the multi version. And anybody using DAI would still interact with this old contract unless we expect that DAI and all these like popular tokens would upgrade to like the new address space. And maybe this can happen if there is like enough incentive, meaning interaction, you know, from the old address space to the new one is really expensive. Then of course they would have an incentive to upgrade. But that's like another big question.
Yeah, just to briefly mention, I think even for those projects that wouldn't immediately migrate, and I think if it's really important if we were to really go down this path, that we should be really public once we have a concrete plan, and that there's like a lot of time between publicizing the plan and actually doing it on chain. So all of these projects can have their migration plans kind of like in place before that. But also I think even for something like DAI, it's very likely that there would at least be a long address wrapper for DAI that then kind of like gets used for 99% of DAI use cases, and only people like actually dealing with the kind of the CDPs and things like that would ever touch the legacy side, even before the migration happens. So
that sounds very optimistic.
No, but also like what I was thinking, like it's important to note as soon as we start actually expiring things, and of course that will only happen a year after the address space extension goes live. But like once we actually start expiring things, continuing to use legacy contracts will become more and more expensive, at least where they continue to kind of occasionally write to previously unused storage slots, right? Because writing to new storage slots will become more and more expensive. So sending DAI natively to an address that has never held DAI before will become more and more expensive. And so I think that's just like a very natural forcing function for people to just use the wrapper that has the same behavior but just works natively. And yeah,
well, the wrap DAI, I think it's nice in as an idea, but then I mean DAI is not used on its own. I mean, you know, the majority of transactions for DAI don't exist for just holding it. DAI is used in other protocols. So you need to also upgrade all these other protocols to use the wrap DAI. there's like a lot of interdependency there.
Right. I'm just saying that's why I feel like we should really like there should be a between a please projects be aware we are doing this and a now we actually did it. There should be a lot of time between these two time points. Yeah.
Yeah, I think we. Yeah, I just wanted to say I guess we ran out of time. I could stay a maximum 10 more minutes if anybody wants to stay, but yeah, I guess we need like another call and many more calls. And yeah, I mean, it's rather a big topic.
So I thought long addresses to compressed addresses is a deterministic process, right? Why do we need a map for that?
Long address to compressed address is deterministic, but you can the inverse you cannot do, right? And the problem we are having is the inverse process, is what the old address space tries to reach a new one.
Gotcha.
Right. Also, just briefly then, because as Alex, you were just mentioning this about like future calls, how do we feel in general about these kind of more working group approaches? I assume, of course, I don't know like about some of the other people here on the call. Like, is it generally like a useful format? Because if it's really like a focused call and only people who want to continue discussing this join, then I don't think there's anything wrong with just having several more of these in the coming weeks. Yeah, is that something people kind of are interested in though, or should we kind of really keep that in like by like just like individual teams jumping on calls just within them? I feel like the semi-open format is kind of like good fit, so people can get involved if they want to. I don't know what's the situation.
I found
like this
valuable.
format.
I don't know if anyone.
Yeah, I think this is really valuable. It feels like there's still a ton more to this. Like, it feels like there's a lot of like initial, I'm not sure if level setting is like the right word, but like that maybe for the next 2 weeks, it makes sense to have like a weekly call. And after that, it might make sense to start spreading them out a bit more or something like that. But it does feel like there's like a lot to cover up front, and having like a couple more of these like initial semi-open calls would be really valuable.
There's probably an obvious answer here that I don't know, but why spread them out over a week? Like, why not just have a call tomorrow or the day after or whenever we can find time?
Sure. I guess my hunch would be like attendance will probably drop but that might be false. Yeah.
Yeah, I'm just wondering, we could also do, of course, smaller just working group calls really frequently, and then just occasionally, I don't know if that when we should just drop back to basically the statelessness or state expiry calls that we could continue to have regularly as a check-ins for people who don't want to follow every single working group but like session, but want to keep updated in general. I don't know, it depends. I'd be generally like I'll be mostly working on this for the next while anyway, so I'm happy to basically do it more or less tomorrow again, but of course it would be helpful if at least like most of the really interested people can kind of all free, so that might restrict things.
I have no personal life, so I'm always free at this time.
That's good.
Yeah,
yeah.
I could join tomorrow at the same time, but Friday we have all core devs, so that probably is a bad time.
So, I mean, what we could do is we could just have tomorrow as like a one-time experiment, see like how many people come, if it makes sense to continue that, or is that just kind of, if we want to do these really frequent ones, just have them be private sessions or something. But we could do it one time tomorrow, just like same time, just to see, maybe, and then decide if we want to continue that. But of course, I feel like maybe there's some people here also who joined because they're like generally interested in statelessness, want to keep track, and there I would say it's probably better to kind of wait for these more broader sessions, these like monthly or whatever statelessness calls. I think we'll also keep them up and probably have a next one, I don't know, within the next 2 weeks or something, 2 or 3 weeks, for like a general check-in, and then only join these working group sessions if you're like specifically interested in the topic, and in this case, an address space extension. Does it sound good? That we could just schedule like a one-time session tomorrow, same time, and continue from there.
Works for me.
Okay, maybe last question then for today, and probably best to then keep it there and like not spend 3 more minutes talking about specifics here. What's people like initial impression here after one hour of conversations? Do we think does address space extension looks like something that's kind of probably feasible, even though quite a bit of work to get it to a good point? Do we think that it's likely to kind of really derail and we won't be able to do something like that on a 2-year timeline, or like ideally, of course, 1-year timeline? What's like, I'm generally like an optimist, so to me it feels like there's something there. We should be able to kind of get it to a reasonable kind of state relatively quickly, but would be helpful to hear other people's impression.
My general feeling is that there's a lot of complexity, and that complexity spans many different layers of the stack. And because of that, we may struggle to find a solution that everybody is satisfied with enough that we can push it through the core devs, basically. That's my biggest concern. It's just like when complexity reaches a certain threshold, it just becomes really hard to just get changes pushed through. Complexity affects people other than the core devs, because the core devs tend to be side on the air of caution when it comes to impacting people outside that group.
I think this is definitely similar to some of the other more complex projects the ecosystem had over the years, and it seems like that there's only so much we can do with brainstorming, and there needs to be likely a few different prototypes and having like wallets and so not just like core, but also tooling providers involved in order to maybe figure out, is there anything which was missed, is any of these like UX issues addressable to them. And I feel like that it's much easier to get them to engage if there's a prototype, so there's like a testnet or something. It's really hard to engage them, and even in that case it's hard to engage them, but it's really hard to engage them if there's nothing like that and there's only like paper planning. So it seems like quite a bit of work in general.
Yeah, that makes sense. Yeah, I also feel like basically trying to get to the best possible version that we can see right now, kind of like relatively soon, over the next few weeks, even ideally, lock that in, start developing prototypes. I mean, of course, continue to iterate on it on the theoretical side as well, but like actually start implementing things, and at the same time start reaching out to these important projects in the space. I mean, even just like to the Solidity team, right? To start like getting them to look at, get their feedback. That I think they'll be very familiar with, like, or like in a good position to kind of assess how it will impact existing contracts. Maybe, I don't know, start with like a broader outreach once we are in the beginning to move into the prototyping phase. But I think that would be ideal, of course. So yeah. But then I feel like it makes sense to try and have these working group sessions, even if it's small, right? If tomorrow there'll only be 5, 6, 7 people, I think that's fine. That'd be helpful, as long as people are not too annoyed by all these invites that they get. They might then have to decline. I think that's really helpful. Just to try and iterate as quickly as possible. Last question then from my side. Before that's all from my side here. Like Alex, with like your team, with the Epsilon team, is like just to kind of understand where you're at. Is that like something that you're kind of willing and prepared to have be like one of your primary focuses for like the next while, or what's the situation there? I mean, of course, apparently you put quite a lot of effort already into like just like to this point. So is that something you're prepared to continue also going forward? I think, like, for example, Quill team, we kind of also are starting to kind of focus more on it in the future. So yeah, trying to assess like how many people are working to what extent on this.
Yeah, the two core projects we work on right now is the object format and this.
Okay, that's good to hear, and also given that there might be synergies between them as well. Awesome. Okay, then that's all from my side. Is there anything left for today's call?
Yeah, for tomorrow, yeah, please try to also read the specification which is linked on the top, because that should at least give a baseline of yeah, what is the current like idea.
Makes sense. And should I continue to just kind of like use the existing full statelessness call list for invites for these working group sessions? I don't really see a good way of kind of narrowing it down to only people interested. So I assume it's probably best to just keep it wide and have people decline if they don't want to come, rather than handpick people who might be interested. Yeah, so I'll just go ahead with that. Yeah, and I'll try to include the links again, just saying this kind of specification primarily just to get people to read them. Good. Then from my side at least, that's all. Thanks everyone for coming, and thanks Alex for leading the session, and probably also leading tomorrow's session already. Yeah.
Right.
Any last words?
That's good.
Oh, okay.
Talk to you tomorrow.
Bye.
Bye-bye.
Thank you.
Bye.
Thank you, everyone.